Okay, let's start. I am Pharma Omics. Today's lecture I will tell you about LFQ intensity, quantification, LFQ mean ratio count. After normalization, quantification step is processed. In the previous lecture, we talked about normalization. Today we will talk about quantification step. Quantification in Maxquant LFQ have three steps: calculate pairwise ratios, least square analysis, and rescaling. After normalization, quantification step is processed. Let's look at first step. Calculate pairwise ratio. In this step, there is important parameter, minimum ratio count. Minimum ratio count is minimum peptide number required for ratio calculation between two samples. This parameter means that there is sufficient information available for a protein based on the number of measured peptides contributing to the ratio. When a protein does not meet the specified mean ratio count threshold, it is excluded from the quantification result, which remove proteins with unreliable quantitative information and focus on proteins that have a sufficient number of reliable quantitative measurement. If you increase this value, you can get more accurate and meaningful data. But you can also lose quantification information because of strict criteria. For example, if mean ratio count is 2, it means that at least 2 peptides should be present in both two samples to calculate ratios. Table below shows that peptide intensity information in the BSA protein. Peptide WXYZ is included in BSA protein. Let's see sample A and sample B. Sample A has peptide W and peptide X, and sample B has peptide X. So peptide X is present both in sample A and sample B. As at least 2 peptides should be present, but only one is present, so the criterion is not met. Ratio count between sample A and sample B could not be calculated. Let's see sample C and D. Peptide W and peptide X are present in sample C and D, which meet the criteria. So it can make ratio between sample C and D. Okay, from now on, let's calculate ratio between sample D and E. There are 3 peptides, or peptide W, X, Y are present in sample D and E. So it can meet the criteria for mean ratio count number 2. First, let's calculate each peptide ratio sample D and E. Peptide W ratio is 100 divided by 50, so it is 2. Peptide X ratio is 200 divided by 50, so it is 4. Peptide Y ratio is 300 divided by 100, so it is 3. So sample D and sample E ratio is median of 2, 4, 3. So it is 3, meaning that BSA protein intensity in sample D is 3 times bigger than sample E. And we calculate every pairwise protein ratio. In the table, bolded letters indicate that a ratio value exists. Otherwise, the ratio value does not exist. Let's look at sample B. Sample B doesn't have any pairwise protein ratio, as it has only peptide X intensity. So LFQ intensity of sample B is 0. After calculating every sample pairwise ratio, we got 6 equations. Now we have calculated ratio between samples using median of peptide ratio right before. And we should find intensity values. So we have 5 unknowns and 6 equations. We cannot solve this problem as the number of equations is more than the number of unknowns. We call it overdetermined system. To solve this problem, least squares analysis is used in Maxquant LFQ algorithms. Using these algorithms, each intensity value in samples can be calculated. I will skip detailed least squares analysis. I think it's very mathematical calculations. After that, we got intensity value of each samples. Final step is rescaling the whole profile to the cumulative intensity across samples. The purpose of rescaling is to preserve the total summed intensity for a protein over all samples. For example, if intensity of sample A is 2.1, which scales to 21,000 based on cumulative intensity across samples, and intensity of sample B is 0 as it couldn't make any pairwise ratio between other samples. Same rescaling will be applied to other samples. Finally, we have the LFQ intensity value. Okay, there are two steps for calculating LFQ intensity: normalization and quantification. Today, we learned about quantification. Quantification uses fold changes in the abundance of each peptide between two samples, which are used to extract much information for quantification. Minimum ratio count is minimum peptide number required for ratio calculation between two samples. If you increase this value, you can get more accurate and meaningful data, but you can also lose quantification information because of strict criteria. Okay, thank you for watching. See you in next video.